This webinar, Assisted GNSS with Imaging Sensors and 3D Models for Mobility Applications, is part of the NAVISP program. NAVISP, by its acronym, means Navigation, Innovation and Support Program, and it is a specialized division of ESA which aims to develop cutting-edge technologies, effective products and services that would foster and maintain the competitiveness of the European sector regarding existing and emerging non-EU solutions. The webinar, held on the 6th of July 2021, explained the scope of the thematic window and how to apply as a funding mechanism to support developing products and services in the position, navigation and timing field, englobing the GNSS. The webinar included presentations from a panel of external experts to illustrate the subject of assisted GNSS with imaging sensors and 3D models for mobility. Floris van Klashorst from Spacetech Partners explained what global trends will shape urban mobility. On the technical side, Paul Groves from University College London showed how the use of 3D models and imaging sensors improves the accuracy of GNSS. Soumya Gopal from the map-making company HERE showcased the next-gen maps for humans and machines that use multi-dimensional, highly detailed geometry of cities to produce an extremely accurate navigation solution. Alison Londis from NVIDIA finalized the webinar by highlighting the benefits of using a simulation environment to accelerate the training of artificial intelligence algorithms for autonomous cars.
So first thing, thank you everybody and welcome to join us in this GNSS with imaging sensors and 3D models for mobility application thematic window that we are starting now from NAVISP. My name is Olivier Meyers. I'm a NAVISP PNT competitiveness engineer working in NAVIS competitive office. I got my telecommunication master's degree in the Polytechnic University of Valencia, but the most important aspect is the background in industry, where I have been occupying different positions in design engineering, leading to development of innovative products in different markets, mostly aerospace, telecommunication. Then I started to work in ESA, and then there I supported and coordinated some R&D, the risking, and also close to market activities together with industry. Okay, so you have already a glimpse on me. I will be your presenter during this path. Just want to remind you basic rules to have this webinar going smooth. So please mute your microphones, of course, because of the background noise and to hear well the speakers. Then as well disable your video camera. We will have a dedicated question and answer sessions at the end of the workshop. You can always post your questions on the chat, but so far refrain to that, just on the chat till we reach the question and answer sessions. Attendees may ask questions in the general chat and the speakers will reply, but again, as we said at the end of the session. So this meeting is recorded and will be posted on the NAVIS website, and for sure presentations will be distributed at the end of the workshop. This webinar is made of, let's call it 3 main blocks. First, from ESA side, we will present the program. Then, and this will be done by Pierluigi Mancini and Rafael Lucas. We will then have a block from the side of industry, where first the use cases and market perspective will be depicted, and then we'll have a block of technology solutions that would provide what will be needed, will sustain these use cases opportunities from the view of companies and to fulfill the market needs. Finally, we will have the moment where Alessandra Fiumara will instruct all of us how to engage with NAVIS, ESA NAVIS program. and make real the ideas for products. And in the end, we will have the question and answers as I was anticipating before. I don't want to miss, sorry, I presented myself, but I want also to mention that Emilio Crespo is assisting me, and I have also Thomas Schultz that from our group that will be assisting me as well. Okay, so time for presentations. Now is the turn of ESA site and knowing more about the NAVIS program. Pierluigi Mancini, who is the NAVIS program manager, will give us these introductions. He has a strong background from more than 30 years experience in the space sector. And also his education reached the level of PhD. He participated along the several years on R&D and spaceborne radar domain, and he has involved in several ESA missions such ERS, NVSAT, Small Geo, etc. Also participated in the creation, or was the creator of the Integrated Application Program in the Telecom Directorate. And as I said, currently is heading the NAVIS program in the highly competitive and rapidly evolving global market for satellite navigation and PNT. Don't forget that we are covering both. Pierluigi, the floor is yours.
Thank you very much, Olivier. Good morning to everybody. I will take you for a small trip in NAVISP, and essentially I just wanted to give you a few messages that you will keep during all this discussion. This is the second thematic window we are proposing, and I would like to tell you why we are doing this in the frame of NAVISP and why NAVISP is an enormous opportunity for you. Next slide, please. We did NAVISP to try to shift a bit the center of interest of ESA. I mean, you often heard that ESA is an ESA-centric mechanism. Today, the time is changed since the creation of ESA. We have to be capable to facilitate the development of European product. It can be product at different type as well as services, but we have to facilitate. We are not anymore in the ESA-centric world. We, of course, we have some specific expertise due to the system capability both in Galileo and EGNOS, but we want to stretch the boundary of ESA. I mean, there is no solution on the market that can be successful if it's not integrating also different technologies that have practically nothing to do with space. This is often very much the case also in other sectors, can be Earth observation or telecommunication. So essentially, we never talk about GNSS, we talk of PNT, so the broader sense, and we want to keep this broader sense. This means enlarging the type of player, trying to attract different type of company that today don't know even these exist, and making sure that we can blend know-how from space and not from space in order to obtain successful solution. What is the end goal of this program? The end goal of this program is to make sure we have a consistent presence of European actor in the worldwide market. That today is not the case. There are investments going on, but it's not yet the case. It is a very difficult task. There are legacy infrastructure that are pushing very hard, namely in US, but in China is coming up. And of course, there are many legacy companies that are based as well in Japan and so on. So the challenge is important. The threat is also important because most of this market is open. So some of these actors can come in Europe and sell their own product. Therefore, we with NAVISP, we are trying to help this type of dynamic. Next slide, please. So the program is well known to all of you. It's essentially a program that is built with three elements and is built to facilitate company essentially to develop their own technology and services for the benefit to succeed in the worldwide market. The program up today is practically at the end of the second phase. It's missing another year and a half to start the third phase. We can see a lot of countries participating. It's an optional program. I should be careful to say this. So it's a program in which there is the interest of member states or not to participate. The nice part of this program is many activity coming from company, not from space, and also a lot of co-investment. So that means generating a global amount of money that is quite considerable. So far we can recognize, and we are pretty sure there will be a third phase even faster than the second phase. And this is the result to have injected the new mentality. And I have to recognize that a lot of the colleagues around the table have been actually helping from the beginning to create this program, injecting ideas so on. And some of the key speakers were very much at the heart of our thinking. Next slide, please. So this is a classical slide. It's about mega trend, but you can see that whatever you talk in any economic domain and in every sector of industry, you will realize that as a matter of fact, P, N or T, or P and T all together, depending on what is the sector, is at the heart. It's very difficult to think that we do not have any of the main drive and the main challenge of the future industry, not basing their know-how and opportunity on P&T. So therefore we are at the heart, and this is one of the reasons of the success, is essentially we see many stakeholders interested in this program. And I can tell you that today we are expecting something like more than 200 people participate. This is a sign. Last but not least, the next view graph, please. So essentially, NAVISP, I invite the NAVISP is trying to attract different players. This is the second webinar. Is essentially focused on assisted GNSS for mobility application, integrating different type of sensors. This is a way for us to open a window on NAVISP in different sectors where there are new stakeholders that might have benefit using NAVISP. So I'm very much hoping that via this instrument we can attract more and more players. So thank you for your attention, and I hope we can all, you can enjoy the five benefits of this webinar. Thank you.
Thank you, Pierluigi, for this presentation where we learn the spirit of NAVISP. Now, next presentation is from Rafael Lucas, NAVIS Technical Program Office Manager. As a short introduction, he got his telecommunication engineering degree, master's degree from Barcelona University in 1988. And what is really more important is the long experience, 30 years of experience in satellite navigation that he has, and he has occupied several areas of responsibility within EGNOS, Galileo, and GNSS evolution programs in the European Space Agency, in ESA. So his knowledge goes from inception studies, system engineering, service development, and technical development. Please, Rafael, the floor is yours.
Okay, thank you, Olivier. So next slide, I will talk a little bit about the relation between the NAVIS program and the role of the thematic windows in the program. So the thematic windows are an instrument for the program to attract the attention of the P&T ecosystem, basically of you attending this webinar, to the opportunities which are offered by NAVIS, by the program, to support the competitiveness of industry into potentially high growth application areas. The instrument, the thematic windows, this follows our recommendations by NAVAC, our committee of wise men, senior external experts which are advising the program. Other recommendations from this group of wise people included that the program should encompass all aspects of P&T technology, meaning going beyond the traditional space technology of GNSS, but also to cover other augmentations. Also to address the wide P&T ecosystem, and in particular to encourage its participation on non-space players. And this is really a leitmotif of the program. We really are interested in attracting the non-space players because we think that they can bring a lot of technology know-how to the P&T solutions. And also to increase the maturity of the results of the activities in the program by implementing demonstration and pilot projects. So all these encompassing aspects of P&T technology, addressing non-space players, increasing the maturity of the results, all these are objectives of the thematic calls. Next slide, please. So as mentioned by Pierluigi, we have already launched a first thematic window. This was launched last year in September on the topic of using the 5G cellular networks for the position, navigation, and time. This thematic window was quite successful and confirmed the validity of the thematic window instrument to support the maturation of the technologies in the program. And also to attract players from the non-space domain. Actually, we had now something like 16 projects or thereabout in different stages of implementation. So we consider that this thematic window has been quite positive, and this has been the motivation why we are following up now with this thematic window. Next slide, please. Now, if you want to know more about the recommendations of NAVAC, this committee of senior advisors to the program, you can go to the NAVIS website, navis.isa.int, download the report, which was produced in the mid-2019, covering the period from the start of the program in 2017 to mid-2019, so basically 2 years and a half. And there you will get a flavor of the activities which are being implemented in the program, and also you will get all the recommendations of the committee, including this implementation of the thematic window. Next slide, please. So now going to the core of the meeting today. So why are we making this thematic window, in particular in the domain of imaging sensors and 3D models? Well, as you know, urban mobility use cases required ubiquitous, meaning 100% available, reliable, meaning safe and integrated solutions, and resilient. Resilient solutions means that your PNT solution should be resistant to whatever disturbances, in particular interference. So having a ubiquitous, reliable, and resilient PNT solution is something that cannot be provided only by GNSS and Galileo, and in general GNSS. So we are in Europe having a very wonderful system which is called Galileo, but Galileo and in general GNSS, including GPS, GLONASS, Beidou, and all the other systems, they cannot provide that type of ultra reliable, ultra available, and ultra resilient solution. So to cope with all these challenges of the urban environment, there is a need to introduce augmentations, and that's what we are addressing in this call. Now, on top of that, from a market perspective, the introduction of advanced technology in urban mobility is a very promising high growth application area because of the improved efficiency, reduced emissions, and all the aspects which will be covered in the presentation by Floris van Klaashoort from Space Tech Partner later on. Next slide. The augmentation of GNSS with 3D maps and imaging sensors, this will be covered in a wide sense, covering all the technical implications of that in the presentation by Paul Groves from the University College London, while the details of the state-of-the-art of the high-fidelity 3D maps, this will be covered in the presentation of Sonia and Gopal from here, and the state-of-the-art on the processing power for the users in the cloud and the application of artificial intelligence. This will be covered in the presentation by Alison Loudens from NVIDIA. So I think that all this will give you quite a wide perspective of the possibilities on this domain, on the domain of the thematic window. And finally, the last slide. So just to conclude that with this thematic window, we tried really to support the implementation of proof of concept demonstration projects, pilot projects, you might call them, or the implementation of national test beds to support the introduction of these technologies in mobility applications. With this, reinforcing the message which was given at the beginning by Pierluigi, NAVIS will continue to stretch the perimeter of the advanced PNT technologies, going beyond GNSS and covering the real-world technologies of augmentations. And our aim is not more than supporting the competitiveness of the industry by supporting the development of products and services, or to support the implementation of national strategies by supporting the implementation of testbeds in this particular case, and to involve space and non-space stakeholders. And with this, I future thematic window. Okay, so thank you. Back to you, Olivier.
Thank you, Rafael. With Pierluigi's and your presentation, we really got how useful can be NAVIS and why the thematic window, and also we got a view of what is ahead us in next block of presentations. So now, from the side of industry, we have use case and perspectives first presentation that will be given by Floris van de Klashort, Senior Executive Board Member on Space Tech Partners and Senior Advisor. So long CV, Floris, you got your degree in mechanical engineering at the University of Delft and a Master of Robotics and Control System. And in industry, you really have a long experience with being SVP on Volkswagen Group in Germany, leading transformation and self-driving system, also VP on connected services, on Renault-Nissan Alliance in Paris. You build the first Alliance cloud services platform. You work also on Nokia. And then later on in here, you lead the automotive, which is leading automotive group. You build an award-winning connected infotainment services that was deployed to car manufacturers around the world. So you got good knowledge on the market. Please, Floris, the floor is yours.
Thank you very much, Olivier. And thank you very much for the opportunity to present, and welcome everybody. So today I will be sharing some market perspectives, some trends and observations, and also some personal views around urban mobility. I think this is a topic which is very much in discussion around the world. I think you can read about it every day, and it's also a topic in which more and more stakeholders get involved. Maybe it started from a technology point, but regulators, the environmental stakeholders and industry, the local governments, and also companies like yourself are now getting into this mix, because it's really a problem or a challenge or an opportunity that touches everybody every day, right? Particularly in the larger cities, in the urban areas around the world, that all share the similar challenges related to mobility in the overcrowded city, with the lack of space, with the growing population and more. So on the first slide here, I'm showing a couple of global trends that I believe will shape mobility generally. And I believe those trends are unavoidable for most of us, and they continue to drive and accelerate the renewal of mobility as we know it globally today. Of course, the first one, this is not new to anybody on this presentation, I believe, or on this webinar, but it continues to be a major force of change, which is the rise of the megacities. With the high concentration of people that come with all the challenges together, right? It's already present for decades, but continues to be a strong driver for rethinking the way we live and we work together. It continues to be on a sharp incline, with 90% of the people living in cities in the next coming 40 years. So this is unavoidable. We see it every day. We read it in the newspapers with the migration of people and hundreds of thousands of people trying to improve their lives. And this is something that we as a society have to cope with. At the same time, I think what has come up is on our environmental compass, that transportation is one of the larger contributors to the CO2 emissions, right? With about a quarter of the total emissions produced, 72% of that from road transport. It's unavoidable that this is an opportunity and a must for the industry and the society to act upon. If you look at the higher concentration of people in the city and the contribution and the need for them for mobility, this is a factor that you cannot ignore. So then, if you look at, I would say, an overarching trend is the steep increase of energy used per person, per capita. If you look at it over the years, you see it in the graph. It's a bit small, but you can look it up on the net. So that there's a enormous steep increase of energy per capita, combined with the growing world population, combined with the need for mobility in the cities, you can see that those three trends together put us on a clear collision course. There is a need for change. There is a need for rethinking the way we do our mobility. And I hope to put some ideas and some trends in your minds here. Next slide, please. So to cope with these huge challenges, I think one important thing that we see today, much more than in the past, is that local governments continue to take more control globally. In the last few years, I've seen the numbers of about 400 larger cities in Europe alone issuing RFIs or issuing tenders publicly around mobility systems for cities to allow them to start orchestrating the mobility systems in their cities in order to meet the demands of today's society in terms of the freedom to move, the affordability for mobility for everybody, of course, environmental requirements, and also making the cities more livable again. One very important, I would say, initiative that has been standing out and that has been copied by many cities all over the world and is this 50-minute city concept by the mayor of Anne Hidalgo in Paris. It's a renaissance of the neighborhoods with the clear objective to have for everybody in the city a 15-minute vicinity of everything that everybody basically needs. And this is being copied across the world as a good target to take the streets back from the cars, right? And change the infrastructure from the cities in favor of pedestrian, bicyclists, small shop owners, local economy, and taking it away from the cars that for decades have dominated the design of the cities and returning the streets to the people. And this is not necessarily a bad thing. Also economically, you see the examples. One example of Times Square, which I'm sure that many of you have been there in Times Square. I live myself in New York, and it was a horrible place to go because you couldn't cross the streets. It was overcrowded with cars. It was noisy. You started to avoid Times Square. Pedestrianizing Times Square again has totally turned that around with a relatively very small total land area. It has superseded the growth of the district, and it's a reviving place now again in the center of Manhattan. What we also see as a way to cope with all these challenges is that we see a mix of modes. Today, it's predominantly the vehicles. In some cities, in some countries, you see a larger part of pedestrians and bikes maybe, but cities start experimenting now with a much richer mix of modalities to optimize the mobility options in the city to support that new 15 minutes model. So that has implications on what license do you give to mobility providers? How do you set up the infrastructure? How do you change? How do you build your new cities? How do you renew the old cities? And taking these mix of modes into account in those plans is a very important part of the orchestration that local governments are taking today. Next slide, please. And this is not only about new innovations, right? This mix of mode is often a blend of the old and the new, with revised traditional modes of transport, either revived in technology or revived in business model, right? Ride-hailing is, of course, a taxi, but technology made it much more pervasive, much easier to handle, much more cost-effective for most people to take than the traditional taxi business. Trams have been there for years, but putting freight trams in the evening or the nights to have the local transport of goods in the city is a new application of an existing mode. Elevating pedestrian and bike infra above the existing infra are other examples of revived traditional means of transport that get new focus and where the design thinking and putting the consumer first has really renewed the way that we think about them. They get, of course, combined with innovations like autonomous technology, both for people and for goods, right? Urban freight and robo-taxis, personal mobility modes like bike sharing, e-scooters, and let's not forget the regional mass transit options like Hyperloop. On this picture in the slide, you see the dedicated and the shared infrastructure. It's very important to always keep that in mind. Mass transit from city to city or at peak hours will remain an important part of the mobility mix. There is no substitute for dedicated infrastructure. You can never have the capacity of the amount of people that you transport by train, for instance, with robot taxis. That will create a massive hard impact in the cities of too many vehicles. So it's very important that you continue to shape and create room for dedicated infrastructure that has a different purpose and a different benefit and a different value, and the shared infrastructure where you have multiple modes of transport on the same sharing the same space. Next slide, please. So I think, you know, when you read about mobility, when you talk about mobility, the majority of the innovation and attention today is on land-based mobility. But water-based mobility also sees renewed attention, and especially in the cities where it's available, water-based mobility can offer crucial capacity increases and offer unique flexibilities in various fields of application beyond transport, such as tourism, local government services, temporary infra, and more. You see, there are some pilots going on in Amsterdam where the variety of use cases is enormous. You know, it is temporary infra on the waterways for festivals, for restaurants, temporary structural interfaces to have temporary like bridges, temporary ferries that put in place for events that take place, so to avoid the high cost of permanent infrastructure, garbage collection services at night. Autonomy is being reviewed there also as one of the benefits. So while it will probably seldomly be served as a main means of transportation, where available, the unique characteristics offer unique options without the permanent cost of infra, without the environmental impact of building, and the ability to have many use cases with one sort of modality. So I think there's promise there. Of course, not for every city, but there's definitely promise. Next slide, please. Also, because I think the waterways mobility, they are going to benefit from a couple of industry trends and facts. For instance, autonomy. You know, if you look at the companies that work on the autonomy stack, they burn about 500 million per year, right? And it takes about 10-15 years. So they're basically 7.5 billion it will cost to create a robot taxi system that works, gets certified, and gets on the road. Waterways autonomy can benefit from that. It's deemed a much simpler use case to achieve. Speeds are much lower. Variables are much fewer, right? There are many different actors on the road. The operating environment is much simpler. It's often much more a shuttle type of connection, making the business case and the viability for waterways autonomy much more achievable. So waterways mobility will definitely benefit from the high investments and the progress being made for land autonomy. Then the second thing, which is, I think, a huge benefit, is that with the electrification of the fleet of vehicles for land, right? We also have a new problem. What do we do with the batteries? Now, this new source of energy, the second life battery, is typically very well suited for water-based mobility. So this significantly offsets the cost for urban watercrafts, and it also serves as a solution for what to do with second life batteries beyond storage, for instance, at home. Because these urban watercrafts, they will also need to be silent and free from emissions, right? The typical second life battery has about 60-75% of the capacity still active, right? That is not enough for the range that people want in their vehicles, but it's definitely sufficient for a reasonable speed of the watercraft of about, 10-15 kilometers per hour, and to serve most urban use cases in tourism and restaurants, in ferries, garbage collection, you name it. So I think waterways is of course not pervasive in every city, but Amsterdam, Chicago, you know, there's many cities where waterways are available, and in defining and building the cities, of course, you can take waterways into account as part of the overall infrastructure. So Maybe not enough attention today on it, but definitely I think an area where we see opportunities to enhance the mobility mix in cities. And then, of course, next slide, beyond land and water, there's air. You know, I think this is an area of a lot of interest, a lot of innovation. Urban air mobility, again, is quite specific in its value. It really has the opportunity to connect cities with each other, connect mobility hubs, create a larger regional city of mobility hubs. Key use cases are, of course, emergency, delivery, cargo, passenger, mission specific like law enforcement, but especially in things like emergency, it has clear advantages over land-based mobility. As you can imagine, even more so than with land-based mobility, UAM as urban air mobility requires very strict governance, regulation, and standardization across the hubs to be successful and see consumer adoption at scale. Right? We are far from that point at this moment. I think it's not only the people that would get into these crafts that have doubts, but also the people that are on the ground and are looking up and feel unsafe and sometimes yeah, they don't see it as a positive contribution to the city, often because of noise and other things. So next slide. Well, there's maybe, especially the people that are in that market that are very optimistic and predict commercial operation as soon as 2025 in the EU. I think many challenges are still open, with safety and public acceptance being the most prominent ones today. Right, public acceptance is around the safety of getting into it or having those crafts above your head. The sound, you know, when we make the city silent again with electric vehicles, electric scooters, and electric trams, then the sound of urban mobility and big drones is going to ruin that again. So that needs to be solved technology-wise, but also infrastructure-wise. So typically the vertiports, you see them high up in the city, so the sound doesn't reach the streets. And that also emphasizes the role of urban air mobility as a point-to-point connection between mobility hubs. But then, of course, you have the disclosure of the vertipoints to the local last mile, which are all things which are today not really solved. Most likely, urban air mobility, in my view, will start with shuttle-like operations, especially for new builds, replacing the costly land-based infrastructure, highways, and infrastructure between cities, or between an airport and a city. I've been in projects and meetings in the Middle East where new airports are built and no highways are built, because they are going to go from scratch with a hyperloop and an urban air mobility link between the airport and the city center. So large-scale infrastructure investment can be avoided, right? Vertiport and these kind of investments, of course, are still needed. But it's, you know, there's studies into what is needed to offset the need for a traditional infrastructure like highway and local roads around that, show that the combination of Hyperloop and the UAM is deemed sufficient in terms of capacity and diversity to accommodate those transport needs, removing that need for highways, parking places, all associated infra and cost, and preserving, of course, costly nature or costly land that can be used for other purposes. So I think a special role, definitely an opportunity, but a little bit further out than the other examples that I gave. Next slide, please. So this is, of course, a very kind of large and complex set of mobility modalities, and how do you start to orchestrate that? And I think what we've seen in the past few years is the emergence of a sort of integrated mobility system with many different stakeholders contributing their parts to the system and some stakeholders orchestrating that system. It's like a vertical integration of business models, responsibilities and ownerships. And if I've made there's many models around there, but this is a model that works on a general level, I think, and good for the purpose of this audience. So it starts with the real world, the infrastructure, the cities, the roads, the air, the waterways as we see it today, which is basically the foundation of everything. That's where we live in, that's where we need to move in, that's where we need to, where we are accountable for what really happens, right? So that is the foundation. And of course, you need to translate that foundation into something that you can work with, a digital representation, a digital reference. This is where the technology is, where the digital maps are. That will be explained also later by here. The NAVISP program, right, with satellite positioning and navigation and timing, the localization systems, the communication infrastructure like 5G, V2X, V2I, things like that allow the vehicles and the mobility assets to communicate with the infrastructure and the world around them. So layer 2 is the digital representation, the digital twin, if you want, of that reality in layer 1. Then in layer 3 we see all the actors, basically the fleets and the number of devices, cars, drones, boats, e-scooters that live in that world, that are being managed, being serviced, get recharged, etc. The fleet management around it. So it's all the things that move around that offer the variety and the diversity in mobility. So that's the third layer that lives in that digital, I would say, representation of the real infrastructure. And the fourth, and here, of course, you have competition. Here you have the companies that build those assets, that lease those assets, that build those fleets and manage those fleets. So this is very much a competitive and industrial layer. And the fourth layer is the service layer, where the mobility provider that offer the different services are orchestrated by local governments that manage the right mix and supply of mobility modes. And what do I mean with the right mix of supply and mobility modes? It can be in time, right? In the morning, we don't know how it will go after COVID with people returning to work and working from home, etc. But, what is clear is that we need a more variability and we need a more flexible mix of modes at different times of the year, different times of the day. But also we need to make sure that we do not forget the people that today miss out on transport, right? That typically in cities or in countries without a lot of public transport, people are deprived of mobility. Mobility is not cheap for many people still. So local governments also have a time to preserve access to mobility for everybody where needed. So they can subsidize, they could help companies to support mobility in areas where maybe from a industrial or from a profit point of view, mobility would normally not be offered. So that's the responsibility of the local governments to manage that right mix, license the right companies, orchestrate competition, encourage competition between them, but also safeguard the equal availability for mobility for everybody. Then the fifth layer is really the consumption layer, where consumers can pick and choose, mix and mingle the mobility modes as they like it and as they need it, always in one integrated system that serves both the consumers' needs, the health of the city, the citizen, and the businesses as a primary target. This is the aggregation layer, where today, in many cases, you still need to go from vertical to vertical to vertical. Right now, we see sometimes that through payment technology, you can use the same payment, but still in most trams, buses, and taxis, it's a different business model. You have to sort of use different methods of payment, etc. That is kind of not very I would say system-like thinking, not very consumer friendly. And this aggregation layer, you see a lot of companies responding to these RFIs of these cities in this aggregation layer, where we offer one integrated service to consumers for that city. So this is the model that we see upcoming, and we see more and more activity and more players in each of these layers. And it's about this vertical integration, which will create this view of a integrated mobility mix in these cities. Next slide, please. So to conclude a little bit with some concluding remarks on how I see the trends in mobility is that definitely, the cities are moving towards a more people-oriented design, people-oriented infrastructure, less car-based design, with an integrated system of many modalities to offer mobility much more in, I would say, in a tailored mode. The cities have an important role to orchestrate that and to balance demand and supply and create a competitive market, and avoid these mistakes and these banalities of these bike share graveyards in China, or the e-scooter disasters in Paris, where the sidewalks are flooded with cheap products that last no longer than 3 months. Those are the wrong initiatives, right? So it's not about opening the floodgate and having competition without boundaries. It's about orchestrating the balance of the demand and supply and creating a competitive market that serves the consumer and the city and not only the businesses. I think road will be pervasive. Air and waterway solutions offer unique value and opportunities. As air specifically, I think, between the mobility hubs, right? Water as a additional capacity and very flexible capacity for temporary needs. Then I think dedicated and shared. You see stories about everything goes to robot taxi, everything goes to shared. I don't believe in that. I believe that it will always be a mix between dedicated and shared infrastructure. There is no better way for mass transit than being on your own infrastructure, where you don't have crossings, where you don't have red lights, where you don't share, where the speeds can be regulated because you own the infrastructure and you have no risk of collisions and things like that. So mass transit will always be dedicated. Flexibility will be much more on shared infrastructure, and they're not interchangeable in that sense. And I believe that the sort of the vertical ecosystem, especially with all the technologies coming in, with autonomy, with the positioning systems, with navigation, communication platforms, this will serve and accelerate this integration of these layers into a vertical ecosystem of mobility in the cities. Thank you very much. This was my presentation. I hope this was useful for you and gave you some insights in mobility and the trends in that. Thank you.
Thank you, Floris. Definitely, I believe we appreciate a lot this presentation where you have highlighted in the end this layer model that somehow is depicting the value chain, the technical challenges, and more important, the opportunities, technological, and even more important again for commercial opportunities. Okay, talking about technology, we are jumping now to the technology block, let's say, with 3 presentations ahead that will try to bring solutions to these use cases and trends that were presented before by Floris. So first speaker of this block is Paul Groups, Associate Professor in the University College of London. He is interested in all aspects of navigation and positioning, including multi-sensor integrated navigation, improving GNSS performance under challenging reception conditions, and novel positioning techniques. He's author of a well-known book, A Principle of GNSS, Inertial and Multi-Sensors Integrated Navigation System. And he's also let's say, participated, in the Institute of Navigation. He received in 2016 the Institute of Navigation Thorough Award and a Fellow of the Royal Institute of Navigation. Sorry for the mess I did. He holds a bachelor's degree and doctorate in physics from the University of Oxford. Please, Paul, the floor is yours.
Okay, next slide. Thank you, Olivier. Good morning, everyone, and welcome to my presentation on the use of 3D models and imaging sensors to assist GNSS. Next, please. So in dense urban areas, GNSS performance using conventional processing is degraded. So in the left-hand picture, we have an image from the City of London, which is typical of European city centres. And we found in this area that the root mean squared horizontal position error was degraded to 16 meters, and errors were as big as 60 meters. On the right, we have a picture of the Canary Wharf area of London, where we also did some tests. This is more typical of North American and Asian cities, and the buildings are bigger and further apart. And this makes the GNSS position errors worse. So we have an RMS position error of 85 meters, and the maximum position error that we had with a narrowband receiver was 500 meters. And the fundamental problem is that conventional positioning algorithms assume a direct path from each satellite to the receive antenna, whereas in reality, GNSS signals are blocked, reflected, and diffracted by buildings. Next, please. So there are at least four ways we can improve GNSS in dense urban areas. We can optimize everything in conventional GNSS positioning. We can deploy extended coherent integration, known as supercorrelation. We can use 3D mapping aided GNSS positioning algorithms, and we can aid GNSS with imaging sensors. And the last two topics are the main focus of this morning's session. Next, please. So we'll start by optimizing conventional GNSS positioning. So the first thing is to use a good antenna, and this gives you higher gain for directed signals than reflected. Next, please. Step 2, use all available GNSS satellites. This maximizes the number of good signals that we can receive. Next, please. Then we use high chipping rate signals where available. These are less vulnerable to multipath interference than low chipping rate signals, but they're still vulnerable to non-line of sight reception. So we have now Galileo E5 signals, GPS L5 signals, Beidou B2 signals, and a few GLONASS L3 signals. So these are better signals, and we should avoid dual frequency ionosphere correction, because then that not only brings back in the multipath errors from the L1 signals, it actually blows them up because of the way the signals are combined. Next, please. Then we want to process signals to minimize multipath. So where we have to use the old E1, L1, and B1 signals, we should use multi-correlated processing to minimize the impact of multipath, and we should also use carrier smoothing for mobile applications, which helps to average out multipath effects. Next, please. The fifth step is then we use stronger signals only. These are less likely to be non-line of sight, as the diagram shows, with the non-line of sight signals in blue and the direct line of sight signals in red. Then our sixth step is we should implement advanced outlier detection. Because non-line of sight and multipath contaminated signals will be inconsistent with the others, we can use consistency checks to eliminate a lot of the bad signals. Next, please. However, these steps only work if we have enough good signals in the first place. We need at least 5 direct line of sight signals, and that assumes excellent geometry. With more typical geometry, we need at least 6 or 7 direct line of sight signals. If we don't have them, more advanced techniques are needed. Next, please. So the first of our advanced techniques is extended coherent integration, also known as supercorrelation or SGNSS. So you're implementing coherent integration times in excess of 1 second on low-cost platforms that are undergoing arbitrary motion. So to compensate for the motion, inertial sensors are used. Algorithms are used to compensate for receiver clock drift, and then navigation data needs to be removed, or ideally data-free pilot signals used in the first place. So the carrier frequency varies differently for reflected signals than it does for the direct signals. With supercorrelation, the receiver tracks the carrier frequency variation of the direct signals, and this tends to weaken the reflected signals with respect to the direct signal. So it reduces multipath interference and weakens non-line of sight signals. Next, please. So these graphs are histograms showing you some results of some experiments we did with focal point positioning in the Canary Wharf area of London using a narrow bandwidth GNSS receiver and conventional GNSS processing. And what we found was that in these conditions, the root mean squared horizontal error was approximately a factor of 5 smaller using supercorrelation with carrier smoothing and code outlier detection than using basic conventional correlation. Next, please. So now we move on to 3D mapping aided GNSS. 3D mapping of the world's cities is now widely available, and projection technique can rapidly predict which satellites are directly visible at multiple locations. Next, please. In addition, ray tracing can be used to predict the path today of non-line of sight signals, enabling correction of non-line of sight errors, and it can also be used to predict which of the direct line of sight signals may be subject to severe multipath. But the computational loading is very high. However, all predictions from 3D mapping, both visibility predictions and path delays, can be pre-computed and stored on a remote server. Next, please. So the simplest way of using 3D mapping aided GNSS applies if the position is already known to within a few meters. Then we can either use simple satellite visibility predictions to exclude non-line of sight signals. So we go from having a mixture of good and bad signals to having good signals only. Next, please. Or if we have path delay predictions from ray tracing, we can use them to correct non-line of sight measurements. So we now have a large number of good signals. Next, please. However, we still need outlier detection to mitigate the effects of both out-of-date 3D mapping and the effects of buses and trucks, etc., which will block and reflect the signals but won't appear on the mapping. Next, please. However, we have a problem. In order to predict satellite visibility and correct non-line of sight signals accurately, we need a good position solution. But to get a good position solution, we need the predictions of satellite visibility and/or non-line of sight path delays. So each depends on the other. We have a classic chicken and egg problem. So how do we solve this? Next, please. So we start with an approximate position. This then gives us multiple candidate positions within a search area of radius a few tens of meters. Now, different satellite visibility predictions and different non-line of sight corrections apply to each position within our search area. So more sophisticated positioning algorithms are then needed. Next, please. So first of these is what I call likelihood-based 3D mapping aided ranging. And we'll start with the basic approach. So we set up a grid of candidate positions as from the last slide. We then score each position according to how consistent the measured and predicted pseudo ranges are, and we derive the position from these scores. So if we do this without 3D mapping, we get the same position solution as in conventional GNSS positioning algorithms, but we've expired a lot more processing power. When we have 3D mapping, we can use this to predict the satellite visibility at each candidate position. So where a signal is predicted to be direct line of sight at that candidate, we use a symmetric distribution, assuming the pseudo range error is equally likely to be positive or negative. However, if we predict the signal to be non-line of sight from 3D mapping, we use the skews distribution, where we assume that it's more likely to have a positive ranging error. And that's because the path delays caused by non-line of sight reception are always positive. Next, please. With a more advanced version, what we then use 3D mapping to correct the predicted pseudo-ranges of signals predicted to be non-line of sight. Next, please. So there are different ways we can do this. Option 1 is we use ray tracing. This is more accurate, but it's also more computationally intensive. Next, please. Second option is to use an azimuth elevation sky mask together with the street width for scaling. This is much less computationally intensive, but it's less accurate than ray tracing, but still more accurate than the basic likelihood-based 3D mapping aided ranging, where all we know is whether a signal is predicted to be line of sight or non-line of sight. Next, please. A complementary positioning technique we can use with 3D mapping is shadow matching. So in the diagram here, we know where the satellites are and know where the buildings are. So we can therefore work out that if the signal we receive is not direct, so if it's a weak signal or no signal at all, then we're in the orange area of the street on the left. If, on the other hand, we receive a stronger signal, so we assume it to be direct, that means that we're in the green area of the street in the middle or the right. So depending on the signal received, we can work out which part of the street we're in. Next, please. If we then repeat the process using a different satellite, that divides the street into different segments. So by using multiple satellites, we can refine our position within the street. Next, please. In practice, what we do is we use a grid of candidate positions, the same as for the previous technique, and we score each of those positions by comparing the measured signal to noise with the predicted satellite visibility. So the key thing to note here is that we are actually using signal to noise measurements instead of pseudo ranges. So we're using different information. So shadow matching is complementary to pseudo range based positioning. Next, please. So best performance is obtained by combining everything to give an integrated 3D mapping aided GNSS approach. So we start with initialization from least squares ranging or the previous epoch solution. Next, please. Then we implement shadow matching using the signal to noise ratio measurements, and that typically gives us a position that's better in the across street direction. In parallel, we implement likelihood-based 3D mapping aided ranging. This uses pseudo ranges and gives us better performance in the along street direction usually. We then combine the two likelihood distributions, hypothesis to give a combined distribution from which we extract our position solution. Next, please. So in this example here, we're showing you a scoring map for likelihood-based 3D mapping aided ranging, the basic versions. So blue candidate positions are low probability, yellow positions are high probability, white areas are excluded because they're either inside buildings or they're outside search areas. So in this example, we have two high scoring areas. That's two possible positions. Next, please. This diagram is showing you the corresponding scoring map from shadow matching. Here you can see we have 6 possible positions. Next, please. So if we then multiply the two scoring surfaces together, we get our final integrated scoring surface. And here we only have one high scoring area, which gives us a position solution close to the correct position. Next, please. To get the best performance out of 3D mapping aided GNSS, we go to multi-epoch positioning. Just as filtering over multiple epochs improves the performance of conventional GNSS positioning, it also improves the performance of 3D mapping aided GNSS. So our histogram here is showing you the RMS horizontal error of various different positioning methods over our Canary Wharf test area, which is a mixture of high density and less dense areas. So if you look at the orange peak, the second one from the left, That's showing you the single epoch 3D mapping aided GNSS performance, and then compare it with the magenta peak on the far right. This is the filtered 3D mapping aided GNSS performance using a grid filter, and you can see that the filtering reduces the error by approximately a factor of 2. Next, please. So we now have 3D mapping aided GNSS implemented by Google on Android phones. This is now operational in Europe, North America, Japan, Brazil and Argentina, Australia, New Zealand, and South Africa. Google won't reveal any of the details of their positioning algorithm, but they have said that it combines 3D mapping aided ranging, shadow matching, and machine learning. And in the diagram, you can see some of their results. So the yellow line shows the true track reference. The red line is the conventional GNSS position solution, and the cyan line is the 3D mapping aided GNSS solution. So you can see the 3D made GNSS solution is much closer to the reference than the conventional GNSS solution, and it always stays on the correct side of the street. Next, please. So now we move on to image-aided GNSS. So there are many different types of imaging sensor that can be used for navigation and positioning, including but not limited to conventional cameras, infrared cameras, laser scanners, and LiDAR. And there are at least 3 different ways that we can combine imaging sensors with GNSS. Next, please. First thing we can do is image-aided GNSS signal selection. So we capture a wide-angle image from an upwards pointing sensor, as shown in the picture. We separate the sky and buildings in the image. We then compare the satellite azimuths and elevations with the image to determine which are visible and which are line of sight, and we exclude the non-line of sight signals from the GNSS solution. So the advantage of this approach is we don't need to know where the receiver position is at all. Next, please. However, there are some challenges. Accurate detection of the sky in the image can be challenging. Using an infrared image can work better than a visible light image. We need accurate camera orientation to determine how to match the satellite angles to the image. So we can use inertial and magnetic sensors for that. And we also need to make sure that the camera lens is kept clean. Next, please. So the next thing we can do is integration of GNSS with visual odometry. So we can extract features from successive images, as shown in the picture, and compare them to infer motion. We get false matches, so those need to be identified and eliminated, and there are also other techniques that we can use, such as optical flow. So if we then integrate the velocity from visual odometry with position from GNSS, this can smooth out GNSS position errors and bridge any outages in GNSS availability. So it brings similar benefit to integrating GNSS with inertial navigation. Next, please. And then third approach is image-based absolute positioning. So here, the imaging is the primary positioning sensor. It compares features between an image database and the live image and uses that to determine the position of the camera. However, we do need an approximate position to limit the database search area, both to reduce the computational load and reduce the chances of a false or ambiguous match. And we can use GNSS to provide that approximate position to define the search area for the image-based system. Next, please. So to summarize, there are many different ways of improving positioning and navigation performance in dense urban environments. So questions will be taken at the end of the seminar, and you can also email me on p.groves@ucl.ac.uk. Thank you for your time.
Thank you very much, Paul, for this thorough analysis of how image sensors and can help and 3D mapping, and also the problems that may be faced in cities. Now we will pass the token to Somnia Gopal, head of product and as automated driving in HERE Technologies. Somnia has multiple years of experience in implementing solutions with major automotive OEMs, expertise in 2D and 3D maps industry, in cartography, building, and enabling a broad range of B2B and B2C solutions. She has background as an engineer at Bosch, Intermap Technologies, and Nokia. And also working in development, radar, sales, and product engineering positions. She's now director of product management at HERE Technologies, where they provide unmatched location data-driven solutions. Here, the team manages a global portfolio of map and content products that enable location-based solutions for various industry segments like ADAS and HADA automotive, fleet management in transport and logistics, intermodal routing in mobility, etc. Somnia, please, the floor is yours.
Thank you so much for such a kind introduction. Let me start sharing my screen. I just need 1 additional minute because I have 2 monitors here. I just need to get out from the presenter mode. Oh, by the way, can you all hear me?
Yes, we can.
Yes, Rickle.
Okay, that's already a big success. And now can you see my presentation?
Yes, we see it. We see it.
Okay. I was told I have 20 minutes, so please interrupt me if I go over time.
We'll do, but we'll try to avoid. Please go ahead.
Thank you for the very kind introduction. So I lead the automated driving vehicle solutions team at HERE Technologies. Most of you may know, and if you don't, it used to be called Navigation Technologies and NavTech. So we've gone through multiple names, but basically HERE has more than 30 years of experience in map making. And I think when HERE started out, the mission was to make paper maps obsolete. That was the mission statement that was written down. I mean, I wasn't around for that, but I've looked at that mission statement when I joined the company myself. And I think we can now successfully check that off. And our next mission is now to create an autonomous world for everyone. And so I think for me, it's not easy, but very comfortable to talk about map making as we know it, and also to explain how this map making has evolved, not just for us, for people, but map making has actually evolved into 2 different streams, right? There are maps for people and there are maps for cars. And why is this important for us today in this session? It's because it impacts positioning. And we all know that positioning is a multidimensional problem to solve. And so I want to take a few minutes then to explain how these maps can help with positioning. And I think the speaker before me, Paul, already did an excellent job of explaining how we have these various complementing technologies that can be used together to get better results. I actually found that explanation very, very helpful, and I think it sets a very nice introduction to also what I'm going to explain now. And if we have time, I have a small demo that I would like to show at the end of the presentation. And for Q&A, please post questions in the Q&A box, and we will take those in the Q&A session. And if I'm a bit unable to answer those questions, please don't worry, I will find our product experts who can get back to you with the answers that you're looking for. So map making as we know it. So we all know satellite imagery, we all take for granted the 2D maps that we use for navigation today. It's almost a given now to use a 2D map to go from A to B, or even to find A or to find B. But this is evolving. The needs that we have today far exceed the needs that we have, say, 5 years ago. So you don't just want to get into a shopping mall, you actually want to understand which shopping mall entrance you have to drive your car into so that you're in the closest building entrance to get to the floor where your shop is located. And if you look at visualization of maps, even on mobile phones today, it's not just a 2D display, it's displaying the address of a building on the facade of the building. Especially if your address is on the 3rd floor of the building, you want to see even the height information so that you know how to orient yourself to those surroundings. So these needs, even in the navigation and in the 2D display field, are no longer the same as they were, and they are continuously evolving, which means for the last 5 years, HERE has been working on redefining the concept of map making, not just for people, but also for machines, or for cars, for devices, for chipsets. So let's first look at what do we mean by the next gen maps for humans, right? So we are very visual. Human beings are very visual. They desire visual cues. Hey, something happened with my sharing. Oh, I have to share again. Sorry, guys. Can you see this? Hello?
Yes, so we see that.
Yes.
Sorry, I was mute.
Okay. So we as human beings, we desire visual cues to help orient ourselves, right? So you don't just want an instruction which says, turn right in 200 meters. You would rather hear, turn right at the yellow building or turn right at the supermarket. And these are needs that not just apply for car navigation, but it's for pedestrians, for bikers, for deliveries. You know, where is your delivery entrance compared to where is your parking entrance? So it's not just about positioning yourself, it's about orienting yourself, it's about looking for landmarks. So it means you need like a 3D representation of the world. The 2D representation is no longer enough. So the simplest way for a 3D representation is to represent all buildings with polygons and to attach a height to it. So this way, if your use case is just to make sure that you can orient yourself, then you have something to start with. But of course, human beings are more demanding than this. You actually need to see facades and actual textures, and what you see in reality is what you want to see on the screen. So this is why the 3D buildings, which were a simplified city model view, has evolved into these advanced 3D city models and has now become even premier 3D city models where you can actually interact with those city models that you have. So you can click on a building to understand which places of interest are in this building, or you can, turn around the building and see, how does the backside of the building look like. And this kind of use cases are not just now for visualization and for navigation, but they're used in simulation, in urban city planning, and sometimes even in military applications. But now we're only talking about maps for human beings or for people. Let's talk about maps for machines. So machines don't care about visualization. What do they care about? They care about position accuracy. So yes, you have roads and buildings, but you also want to understand where the road ends and the building area begins. How wide is this road? How many lanes does it have? Is there a sharp curve coming ahead? Are there objects on the road? Are there barriers on the side of the road? Are there overhead objects? Are there bridges? So why do we need to answer all these questions? Because the problems to solve for machines are very similar, but also different. So the car, for example, wants to know, where am I? Not just within the road, but within a lane, and also longitudinally. Which way do I go? Because I want to plan my route ahead, and my sensors can only see, let's say, 600 or maybe 800 meters ahead of the car. But I want to plan my route, a few kilometers ahead, so that if there's a sharp curve, I brake before I enter the curve and not after. So what maneuvers am I going to make? What's around me? Is there a traffic light that's coming right after I exit the highway? So should I slow down from 120 to 50 without scaring the driver? How should I behave? Are there implicit regulations on the road that I can't see? For example, people from the right have priority. This is not signposted because we as people know it. But how do you let the machine know that this exists? These implicit regulations, which aren't signposted, exist. How reliable is this data? Is there a construction going on? Is there a lane closure? How should the machine interpret the situation, become contextually aware, and react? And this is why we have what we call the high definition map, or what we call the HD Life map. And you can see that there are a number of use cases listed here. And of course, all of this also connect to positioning. I will just get to it in a minute. But the way the HD Live map is created today, it has different layers of information. It is live streamed, it's updated multiple times a day, and there are multiple layers in it, and I will talk you through the layers now. The first layer we have is, of course, the roads, because you need the roads to get from A to B. The path planning needs to happen. You also need to understand what is the elevation of the road slope. Is there a, upslope? Are you going upslope? Is there something steep coming up? You also need to know the curvature of the road and the topology of the road, how the roads connect to other roads, direction of travel. Is there a U-turn? Is there a no left, etc.? But then you expand this also to lane level. Why? Because again, it's a problem of positioning. You don't just need to position yourself within the road, but you have to position yourself within the lane. So you need to understand how wide are these lanes? How many lanes are there? Are you in the leftmost lane or are you in the rightmost lane? And this matters because when you move into a complex intersection and when the vehicle has to plan every maneuver ahead of you, you have to position yourself at lane level for every maneuver to happen. Because lane changes at intersections are where you have the most accidents, for example. It's where drivers have the least trust in automated or autonomous systems. How do you solve that problem? By showing them that you can always position yourself in complex intersections to the right lane, depending on what maneuver you have to do next. How do you do this longitudinally? The lateral problem is solved. You position yourself with the lane topology, with the lane geometry, with the lane width. But what do you do longitudinally? How do you know when you're traveling at 130 kilometers per hour on a highway that you can position yourself longitudinally? You need objects to which you can orient yourself. Objects that are stable, objects that are not seasonal, objects that are reliable enough to be there for a while for you to position yourself. So overhead structures, gantries, utility poles, reflector poles. These are what we call localization objects, because these help you not just position yourself laterally, but also position yourself longitudinally. And my slides aren't moving. Okay, yay. I just want to briefly touch on the lane model once again, because I think it's key to understand why there is a difference between the road layer and the lane layer. So there are three kinds of information that is shown in a lane layer. You have the lane topology. If you look at this, you don't just have the lane count, but also the lane travel direction and the connectivity, how lanes connect to each other. And as I briefly explained, this is something you need when you do these complex intersection maneuvers. And then you have the lane geometry, which means you have the boundaries of every lane, but also the lane drive path or the lane center line. So where you drive within a lane. And lane attributes, for example, what is the lane marking style? Is it dotted? Is it dashed? Is it a solid line? Can you change lanes? What kind of lane is it? Is it a turn lane, a bus lane, a taxi lane? And why is this relevant? Because this, again, gives input to your positioning, right? If you're a vehicle driving in a bus lane, something isn't right. Either you're a crazy driver or your positioning is going haywire. And then there is what we call the lane transition status. This is, one of my favorite parts because my lane assist systems in my vehicle go haywire every time I come to this transition area. So what we mean by transition area is, imagine you have a toll booth. You have 4 lanes on the highway that suddenly expand into 8 toll booths and then again converge into 4 lanes. And you will sometimes see no lane markings before and after this toll booth. So this is what we call a transition area. And this is important because this is, again, situations where the positioning has to be accurate because you have, for example, automated toll booths through which you can just drive through because you have a pass or a credit card, and then you have the toll booths where you have to stop. So imagine that you have a functionality like automated driving. If you have to drive through such a toll booth, you cannot afford to lose positioning even in these transition areas. And this is where this input becomes critical. So I think I've said this enough, and also speakers before me, it is a multidimensional problem to solve. And that is why HERE also has a portfolio of positional technologies. What do I mean by multidimensional problem, right? Of course, we care about accuracy. Do you want sub-meter positioning accuracy, or can you get away with 50 or 500 meters? Because there are use cases that do benefit from those accuracies as well, right? You have asset tracking, for example. And at the same time, you're also looking at coverage. Yes, you would, of course, like to have the best positioning possible everywhere, but you need data. You need this to be available. So what is available worldwide? What is available only on highways? What is needed indoor? What is available in urban areas? And as you can see, there is also overlaps in technologies, right? There is no real clear border, especially when you move to the sub-meter positioning. You can see the HD Live maps with the LiDAR camera, so the image-based positioning that Paul talked about, is in this space, together with the maps, which complement the sensors. But then you also see the HD GNSS, which is the proprietary correctional service that HERE publishes, also in the same space. And imagine if you can put these two together. So complementing technologies used together bring you the most benefits than doing one or the other standalone. And of course, it then still depends on the use case you want to do. Do you just want to do lane level navigation? So in this case, yes, you need precise positioning because you're still doing the navigation at lane level. But if your positioning is off and you show the user incorrect lane guidance, you ask him to go right and sort of turn right instead of going straight. Yes, it's a problem, but it's not safety critical. It's annoying, but it's maybe not fatal. When you move to autonomous driving, the stakes are high. And similarly, we also have use cases like autonomous drones. Again, stakes are high. So it really depends on what are you willing to do. Are you thinking about convergence time? Are you thinking about accuracy? Are you thinking about coverage? Or are you thinking about the use case? That's why we want to offer this portfolio and say, okay, tell us your use case, tell us your needs, and we can find the perfect mix and match from the existing technologies to solve your positioning problem. So this is a high-level architecture of the HERE positioning service. If you see the flow of data here, we have a number of partnerships here that can give us the raw assistance and correction data. And what happens to this raw assistance and correction data is that it's conflated in the platform with other complementing data sets that we have. So it's about Wi-Fi, could it be a Wi-Fi radio map? And I'm just calling out 2 or 3 as examples. It could be the lane layer we just spoke about. It could be a cell radio map. But all of the information that we have, it's conflated in the HERE platform. And then you get a positioning service that is very precise and that is streamed either directly to the chipsets in case you need the positioning engine, or to the devices, depending on how you want to use this. So the key here for us is to focus on the conflation. And this is where I think Paul actually explained this really well about how you can use the different aspects to actually improve your existing GNSS positioning. And that's exactly what we are accomplishing in this conflation in the platform. So if I just focus on this correctional data stream that we provide for HD GNSS, the target accuracy that we have is less than 0.2 meters. And because it's a streaming service from our own cloud infrastructure, we also offer SLAs with it, which is 99.9%. And this is something that can be used for location accuracy for mass market devices, not just vehicles, but it could be mobile devices, it could be assets, it could be industrial automation. It can be used for both of this. And as I explained in the previous slide, so we also provide a positioning engine together with the service, depending on if the chipset cannot handle these correctional data service themselves. And before I go to the demo, I just want to quickly visit the connected vehicle example again. So we just took this one example because it's close to where HERE works a lot with customers on this. We have, for example, the highly detailed maps, what we call HDLM, HD Live Map. And then we have this high definition GNSS positioning correctional service that we create. We also have what we call the HERE cellular signals, which is basically we provide the signal strength and the provider for every road stretch. So that's because everything is streamed. So the HD Live Map is a streamed map. HD GNSS is a streamed positioning service. So because everything is being streamed, if you lose connectivity, you cannot end up losing the entire experience. So knowing whether you have a stretch of bad connectivity coming up or whether your connectivity strength is getting weaker, for example, as you cross borders, whether it's states or countries, it helps your caching strategy to make sure that you're able to see ahead of time and cache information so that you don't lose the experience when you lose connectivity. And then, of course, we have the feedback loop, whether it's getting input from sensors, based on what the camera is perceiving or what the LiDAR is perceiving. This information comes back to our platform so that we have a feedback loop in improving the products. And these are just 4 components that I'm showing from the portfolio, because this is what we would offer to a customer. We would say we have all of these components, and I think for your use case, it makes sense that you take these 4 and use them together for what you're trying to accomplish. And now, I don't know how I'm doing on time. Do I still have time for the demo? It's, I think, a few seconds.
I think if it's a few seconds, let's say a couple of minutes, that would be fine.
Thank you. Then I just have this one demo. This is an example of the positioning service that was done in California to show that you can keep the vehicle, or you can localize the vehicle to lane level throughout using the HDGNSS positioning service. And the underlying data is, of course, our HDLM. There's a bike lane, moving from the bike lane to the regular lane. Intersection, you can see all the traversals. So in conclusion, we have a feature set with both PPP and RTK correction data. We have a cloud infrastructure so that we can stream the data with very good SLA. We have on-device implementations, but also strong partnerships with both chipset and device OEMs. And we have the extremely accurate 3D mapping products, HD Live Map or lanes, or the cellular signals. So we have an extensive portfolio that helps customers choose what they want, depending on their use case and industry segment. Thank you for giving me the time, and I'm happy to take questions in the Q&A session.
Thank you very much, Soumya, for this really interesting presentation. I will take from your presentation, among all what you have presented, the multidimensional nature of the challenge ahead. Thank you very much.
Thank you.
Now it's the turn of Alison Lodes, working in artificial intelligence developer relations around the globe from NVIDIA. So we have now the challenge of how to process everything. So Alison will talk about that. She is a master's graduate in artificial intelligence, combining technical and theoretical computer science with a physics background, and over 25 years of experience in international project management, entrepreneurial activities, and the internet. She consults on a wide range of AI applications, including planetary defense with NASA, ESA, and the United Nations, and works closely with the community of AI and machine learning researchers around the world, remaining knowledgeable in state of the art across all areas of research, internal at NVIDIA and external. She also advises on and teaches NVIDIA's GPU computing platform around the globe. So, Alison, please, the floor is yours.
Okay, thank you for the introduction. Bear with me a second. Just share the screen. I have multiple screens, so let me know once you can actually see. Can you see and hear me okay?
Yes, we can hear you.
Okay, so thank you again for the invite to this event. Hopefully my talk can complement what's already been said by Flores, Paul, Soumya. I focus on both terrestrial but also off-Earth applications, so please bear this in mind as we actually go through. Fingers crossed. Slides are going to move. So just a quick intro to NVIDIA. We started out in graphics and visual computing, but we've actually grown into a full stack platform company, coupling the graphics processing unit, or the GPU, with legacy infrastructure, providing massive parallel compute capability or accelerated computing, providing the ability to code that hardware with CUDA, with over 150 SDKs in a singular software and hardware architecture to developers actually worldwide. And there's many facets to NVIDIA, but accelerating HPC is a main driver of innovation across all kinds of scientific computing. As well as the GPU, we then acquired Mellanox to add the DPU, or the data processing unit, Bluefield, which is the security aspect. So combining unparalleled interconnect with heightened security for more and more complex combinations of our hardware. And what I mean by that is data centers, supercomputers, enabling scale up and scale out for what we call hyperscale technology. So the massive industries like recommender systems that drive most internet traffic today, and also telecoms. But the GPU and our latest addition, our own CPU, and the DPU for accelerated security is this new computing paradigm. This is our own in Santa Clara. It was nice to see Somia's demo there in the familiar roads. This data center was built in less than a month due to the modular setup. Each of those gold boxes that you can see is what we call a DGX A100, A100 being the code for the latest chip generation Ampere. And the DGX A100 combines 16 of these Ampere GPUs with all of the networking, the storage, the CPU, and the memory that you actually need. And Selene is over 560 such units, but you can basically just SSH in and use all 560, or you can just use one DGX A100, or just one Ampere card in that DGX 100, or even just one instance of 1 Ampere. And this is what I mean by modular, but also scalable. And one configuration of these units, what we call superpods, is the world's most efficient form of compute, getting just over 26 gigaflops of compute per watt. It was actually just knocked off the #1 position on the Green 500 list by a fraction of a gigaflop, but it actually features in all entries from 2 to 15. This is a huge part of NVIDIA's business, but the engineering innovation to achieve this trickles down into all our other software and hardware. And the good news is, with this kind of infrastructure, Paul's, what he talked about integrated 3DMA is possible, because GPUs handle the ray tracing compute effectively and efficiently. For those that don't know, this is an Ampere GPU in its PCIe format. It now comes with 80 gigabytes of memory on board. So these and server forms and all the other different formats that we have are deployed across all major cloud providers. One of the first things that I did after joining NVIDIA, which was unbelievably 6 years ago now, is I helped to found what's something that's called the Frontier Development Lab, or FDL. And this is applying artificial intelligence, which is my field, and our platform to space. ESA actually hosts the European arm, NASA hosts the US side. Research is basically accelerated in 2 months super hacks, and we work closely with the FEE Lab at ESA Esrin. It's accelerated in that super hack, then deployed, such as ground station path optimization, which is now deployed at ESOC in Darmstadt. The 2021 program is that's just kicked off. I've no time to sort of say any more about this, but please go to the link for more info, and there'll be a copy of these slides that are sent to you after this. I also work with researchers all over the world. So this is an image looking through the eyes of an autonomous drone that was built by University of Pennsylvania's GRASP lab, and it's now spun off to actually serve the timber industry and provide disaster response. They have a fully autonomous drone now, drone that is capable of carrying LiDAR. Most that you will have seen up to now will only carry cameras, but LiDAR offers these dense 3D maps with centimeter resolution, and they actually run off our embedded, just credit card sized GPUs. And it's interesting to note that Tesla have actually dropped LiDAR. They're now vision based only, so these are, their Tesla range of autonomy capable vehicles. They currently now use, I think it's 8 surround 8K video cameras and no HD maps. But while I agree that AI can actually process depth and velocity of the environment surrounding and much more, we as in NVIDIA prefer the redundancy that actually comes from both camera and LiDAR and HD maps, fusing multiple data streams from multiple sensors. I believe Elon says it's better to double down on vision than sensor fusion. But have a look at, I'll give a link at the end of this talk to Andrei Karpathy's talk at CBPR. At the end, it's actually very interesting to actually see what they're doing. So especially when you get to global scale problems, broadening the field of view, both spatially and temporally, whether it's single collection assets or larger constellations of satellites, high or low revisit rates, each sensor is pulling in a signal and requires the infrastructure that I've very briefly described, DGX, to turn those signals into valuable information. As I said, we have these embedded GPUs and they're actually in orbit now. Many partners putting them up there for onboard compute in smart satellites. But we also have, of course, DGX back on the ground. And interestingly, we also have GPUs on the ISS and partners actually launching the first orbiting data center next year. There's actually one that's just gone up with the Launcher 1 actually. But this is imagery from Planet Labs showing changes to a section of the Bahamas after Hurricane Dorian hit in 2019. This typical image product is tens of thousands by tens of thousands of pixels across multiple bands, requiring massive rescaling to fit into traditional artificial intelligence or deep learning models. I'll show you software that we actually use to do that in a moment. But we're all familiar with Sentinel-2. This is only 3 bands. S2 can collect 10 other spectral bands, so near infrared, VNIR for vegetation monitoring, shortwave for snow, ice, cloud detection, others for aerosol detection and water vapor content monitoring. But the pair of S2 satellites costs approximately 400 million euros, and that's a Google figure. I'm sure folks here would have a more accurate figure. But this is an image of OSK, Orbital Sidekicks Hyperspectral Imager, under the canopy there, far right in the aluminium box. And this is sitting external, or was sitting external to the ISS in 2018. The unit performed nominally for over 12 months running on our embedded GPUs, which cost about 300 euros at the time. It's now been decommissioned and their new 6U CubeSat is being deployed shortly, and major satellite operators are also deploying similar with Jetson, which is what we call our embedded range of GPUs, so Jetsons in space. But also these are being used for ISL for intra-satellite links because it's much more efficient for the job versus deploying larger assets for the in-between, for the actual communication links to make that mesh around the planet even denser. This is the Jetson family, and actually this is the dev kits, the developer kits. So you prototype on the dev kit, deploy with the module, and it's a seamless integration. The dev kits run the same software, support the same features and capabilities as the actual production modules. And in fact, the industrial version of the Xavier AGX module has actually just been released. And that basically offers up to 30 TOPS. So that's 1 trillion operations per second. You're actually at the level of integer rate precision. And that's what I mean by TOPS, as opposed to what you commonly hear as FLOPs, floating point operations. You can actually see the link there for more details. Let me just turn, I don't know if you can hear that volume, but I'll turn the volume off. SegFormer is some of our latest work. We generally think of transformers and neural network architecture for processing voice and sound, but they're also very ideal for images. Let me just jump to the segmentation further. Actually, this will actually do. They're extremely robust to JPEG compression, so you can actually really reduce the size and still remain accurate. But the multi-head attention and the spatial reduction makes it very, very suitable for detection and dense prediction tasks, such as you see here, segmentation, flow, depth estimation. But these vision transformers are very, very robust as well to occlusion or adversarial perturbations like fog, motion, blur, different lighting, whether it's very bright or very dark, and that they actually generalize better than the convolutional neural network. Word embeddings are fed in, and then position embeddings are added. Multi-head attention is basically each attention head attends to all the tokens to refine the embedding. I can do a deeper dive at another time for this, but this is just some of the work that we're doing internally. Geospatial has actually been around, so the field itself, QSpatial, and the latest QGeo. So Q is for QDO, that's the GPU programming language, and spatial, obviously you can get the gist of it, but there's actually an example notebook here. And basically AI is a vast field, so forgive me for using that singular term. But it can rapidly analyze and improve navigation and flow. It can detect anomalies, it can monitor the environment and give these critical insights very, very rapidly. And current research and deployment focuses on smart cities, smart traffic, and transportation, warehouse logistics, defense, but also Earth observation and much more. So code like QSpatial, for example, will accelerate common operations needed in understanding the sensor data with GIS systems, geographic information systems. So this notebook, feel free to go and use it. It takes you through a data set of over 10,000 different trajectories, extracting through traffic cameras, and it reduces computation time. This was actually written probably a year and a half, 2 years ago now. So it'll be even more than this, but the actual notebook will take you from a 5-hour compute time to under 15 seconds, just using a single GPU, and you can actually run it on the GPUs in the cloud. QGeo is still in development, but actually provides accelerated geospatial data processing, LZW decompression. It's very useful for things like pan sharpening and onboard compute for efficient cropping, for example. QSignal is yet another. It sits on top of our Rapids library, which speeds up, and accelerates all different parts like data loading, etc. Most of the gamut of data science as we know it. It's a community-driven development library, so feel free to work with it or go online to learn more about that. But deploying AI at the edge obviously faces unique challenges, and that's whether it's terrestrial or off Earth, and space comms. But servers need to be self-secure. They need to be easy to update, to manage, to deploy, to maintain from afar, obviously, if you're on the ISS, with guaranteed zero downtime. So we have these high-grade security systems that enable all levels of the actual system. So protection of the AI system, the data, the comms, which of course is critical. But it's also imperative for admins to be able to manage the workloads at the edge in the same dynamic and automated way as you would do with resilient on-prem or with cloud, for example. So we have this infrastructure. And we can couple it with things like what we call aerial. So this is for the 5G and 6G community. Paul spoke about the diffraction errors. The aerial platform is specifically for software-defined AI on 5G, we call it, which is basically the deployment of intelligent services with low latency signal processing. And again, that's whether it's terrestrial 5G or SATCOMs, space comms. Aerial is an SDK that provides accelerated radio area networks, and it's backed up by what we call EGX, which is the smaller version of DGX. So these are GPU accelerated servers that can help with, well, here you can actually see network performance on the bottom left there, where you can see throughput, time slot, duration, timing errors and other changes per second represented on the dashboard. And on the right, things like intelligent video analytics can run on EGX servers with our optimized software, but also with containerized applications that you can simply pull down from our central repo that we call NGC. And this includes things like NVIDIA Tensor RT, which really speeds up the fastest possible for inference. You train your AI system, but it's inference that's, when you give it the new information, gives you your prediction, gives you your insight. DeepStream as well. This is another SDK. So DeepStream receives the packets, and it runs, in the next case that I'm going to show you in a second, it runs a pre-trained ResNet model on input streams to perform things like object detections on cars, pedestrians, roadsides, applying bounding boxes to the identifying objects. There's actually multiple application code bases available depending on what you want the artificial intelligence to do. I don't have the time to run through the hundreds that are out there, but also the hundreds of code samples that you can simply pull down that we've already written for you for GPUs. And again, I don't have time to go into the orchestration details, but you can refer to this link for much more, and I'm happy to set up a much deeper dive to go into this. We've worked with all the major players, Ericsson, Vodafone, Mavenir, and more. We actually just did a presentation at the Mobile World Conference Congress that is well worth a watch. So this is just a demo of DeepStream. So all of these HD streams running in parallel on a single Xavier, Jetson Xavier unit. So the capability is quite profound. There is a dev kit also available. So this basically is to jumpstart your vRAN development. So and you can sign up for the early access now, whether it's Reg services, space comms, or whatever the terrestrial service. Again, I can deeper dive into that more. This is what I mentioned earlier about NGC, the NVIDIA GPU catalog. Here, you literally, it's free for anybody to actually use. You can literally just pull down a container for multiple applications. There's over 150 enterprise grade, and they're all validated and tested by us, and also up to date, because there is continual evolution of software. We probably spend more time on software now than we do on hardware. Again, some more resources for DeepStream and Tensor RT, but also the transfer learning kit that again improves and accelerates the actual inference. So that's getting that answer, getting that insight. Things like Tensorly, this is some new code that we just put out at GTC. Actually, that was back in April. Time is really moving quick. Tensorly basically speeds up LiDAR processing at the mathematical layer. This is work by both NVIDIA, Caltech, and Imperial College London. And the collaboration was for tensor decomposition and other ops. Essentially, it's creating much lower flops. So, for example, when you think about high dimensional space, such as point clouds, tensor networks can process point clouds, 3D video or higher dimensional data very, very efficiently. But it exploits the sparsity. And what I mean by that is it's pruning. So less flops, less time to train. The higher the dimension, the more spatial sparsity is pronounced, and the problem only gets worse as you increase resolution. At this resolution, it's about 98%. And what I mean by that is we're wasting 98% of the computation by processing zeros. So instead, we simply save a set of coordinates and values of all the non-zero elements. And we released the code for that, which is called the Minkowski engine. And you can see that link there. So feel free to use that code.
Sorry, Alison, for interrupt you. Sorry,
Yeah.
Alison, we are running out a bit of time, and I would appreciate if you can condensate a bit in a few minutes, 5 minutes maximum, let's say, the rest of the presentation. Sorry again, thank you.
No problem. Okay, so we actually do a lot of work on autonomous vehicles, or AV, and through this work, we've actually extended our work on what's called digital twinning, or working in simulated environments, to safely test and validate robots, cars, trucks, even smart factories. This is actually BMW's factory twin. So this isn't a real factory. This is a digital visualization. It combines facility viz, architectural CAD, equipment CAD, vehicle CAD, scans, point clouds, even digital humans to completely visualize what's going on. So in this virtual environment, you can actually train and test with very, very complex physics. Here, this is their robotic STR, or smart transport robot, and it's running on Jetson Xavier. And it was built entirely in our Isaac SDK for navigation, perception, obstacle detection, and it has both camera and LiDAR on board. So the actual simulation itself leverages what we call Omniverse, and this is advanced physics simulation where you can test with photorealism, with real-time ray and path tracing, and it's built to support use cases across the board. I'm going to skip this, but basically another need for virtual environments is its integral ability to create synthetic data. So there's a link there to the blog for you to learn a bit more from that. Let me just move on. Domain randomization, let me just click that, is very important here, because obviously in these virtual environments, it's very simple to adjust lighting to create different corner cases, for example. Very, very simple, and important again for making robust data sets. For climate, you can currently, I'll skip through this, but we're currently testing it for use in digital twinning climatic processes for weather, for extreme weather, and there's a link there that you can find out a little bit more. Few resources for Omniverse. I'm going to flip through this very, very quickly. But this is work that we've been doing with Volvo. We've been working with them for a long time using NVIDIA's Drive platform. So this is what we call our software stack that covers everything from 360-degree sensor processing, perception, map localization, path planning. And you can pull down a lot of the code here that's available with the Drive platform. Again, just an example of our simulated environments. This is a San Francisco point cloud. Samir showed various aspects of this. You can see it's very, very realistic, photorealistic. So we can actually put this together with our real fleet and combine the two to make an even more robust end result. And this is a very complicated slide that you can look at later to get more information on what we do as a company. But I wanted to just end by showing you this. After reinventing Minecraft with RTX, RTX stands for real-time ray tracing. GANcraft brings the next revolution after what we call physically based rendering. So here the machine learning actually learns the elements of photorealism from massive amounts of real-world data and applies them to rendered 3D. So this is actually really important. NVIDIA's prediction is that the metaverse will actually be 100 times larger than our own in terms of people designing in it, simulating in it, testing and validating in it. And you can do that with just a single RTX GPU. This is Orin coming later this year. and I'll be finishing in just 1 minute. But I wanted to say that the GPU itself has layered mitigation for safety. This is always a huge deal in this. So we've actually put out, so this resource includes our safety related papers, and it's actually worked with UT Austin, basically presenting the limitations of software engineering safety for machine learning algorithms, categorizing a whole load of algorithmic solutions. So do take a look at that. I will skip Jarvis for the conversational AI part to add even more intelligence to solutions. Bear with me a second. But if you haven't already, please sign up for all our code, whatever the application. Just join up to developer.nvidia.com. And for a deeper dive, we have lots and lots of classes online that you can actually go to yourself to actually learn a lot more about many different applications. Here are those links that I told you about CVPR's autonomous driving workshop, very, very interesting, and a number of our GPU Tech Conference talks from back in April. So thank you very much.
Thank you very much, Alison, for this very interesting application where you show the portfolio in both aspects, the hardware and the solutions. I'm sure that will trigger a huge interest in industry. So now we go to the moment that where you will learn how to engage with NAVISP, with Alessandra Fiumara, who is the ESA NAVIS Element 2 manager and my manager. Alessandra Fiumara previously worked as liaison officer at ESA on GNSS evolution program and security applications, has been head of strategic planning office at ASI, Italian Space Agency, and head of ground application system unit at Telespazio. She's currently the manager of Element 2, and she also has got a master in electronic engineering. Please, Alessandra, the floor is yours.
Yes, thank you, Olivier. Let's go back to ESA opportunity for you attendees. So I think that the scene for our initiative has been put very, very clearly by our very interesting presentation that we received this morning. On one hand, we have the evolution of the cities that brings an evolution of the transportation means, air, water, and road, both on autonomy and more integration. Both these evolution trends are based on a accurate, ubiquitous, and safe positioning signal and solution. GNSS is the base of the PNT solutions, but sometimes it tweaks and we need to integrate. And we have seen how visual imaging and 3D models can help GNSS when it is in a short and poor visibility situation. So what is the ESA program that can give an opportunity for you to develop your own products? And it was illustrated by Pierluigi, who is the manager of the NAVIS program. We have multiple programmatic lines in this program, but mainly two are suitable for the development of these PNT solutions, what we call Element 2 and Element 3. The objective of Element 2 is to develop a commercial product. So any company that has in mind to develop or to further develop a product that integrates visual imaging data with GNSS can submit a proposal in the framework of Element 2. Element 3 is more linked to a product or a facility that is linked to a national priority of the participating state. The implementation of these programmatic lines are very simple. There is an open call where you can connect. You can submit the proposal, and we will co-fund in Element 2 to retire the risk of in order for you to develop the commercial product. In Element 3, we will fully fund the activity. In both cases, we need the support of the member state of the country where the activity is developed. One of the most interesting things of these programs is that it is the tender that defines the activity to develop and to propose. Next slide. This is not the only benefit of this programmatic lines. So you define the activities, the cost, and the objective of the activities. The contract is given in direct negotiation. We try to streamline and smooth the procurement process in order to be very fast in awarding the contract to you. There are facilitating instrument for the small and medium enterprises. We can give 35% of advance payment to the small and medium enterprises, even if they are subcos and not prime. Another important thing in this field is that the IPR that you develop within the contract remains with you, and moreover, the ownership of the product that you develop will belong to you after the conclusion of the contract with ESA. Of course, we are in a commercial sensitive area, so all information is treated as confidential. And ESA, because we are no more in an ESA-centered world, but we are really pushing and supporting the companies and the outside world, is what we call the facilitating mode, meaning that we are not in a competitive mode. We can consult with you, we can help you in preparing the proposal with all the details that we need in order to well evaluate it. So we are really in a new mode of function of ESA. Next slide, please. Just to tell you that we are really successful so far. We are running 120 activities in element 2 and element 3. 60% of the primes are small and medium enterprises, and almost 50% of the companies have never worked with ESA before. And this is really a success for the ESA initiatives in this framework of NAVISP, because we enlarge the perimeter. We are not in our space sector, but we enlarge and we promote the use of space technologies in the various market area, and positioning is support in many economic areas of our modern society. So how to apply, how to participate to this process, to these programmatic lines? You have an idea of a PNT product, you can consult with us. You have to trigger the process by submitting us an outline proposal. Outline proposal is a very simple and short document, 5-6 pages, illustrating your idea, the starting point, the final point that you want to reach, the costs and the activities that are needed to be developed. At this very starting point of the process, we ask you either to interact with us or directly with your delegation in order to see if they agree on your idea and if they have the financial availability supported, because, as I was mentioning, the contract is given in direct negotiation based on the support of the delegation. Then, after this very short process of the outline proposal submission and assessment, our goal is to give you a feedback in 10 days. You are invited to submit the full proposal. The full proposal is a more complex document, a more complete document that will analyze all the aspects of the activity that you are proposing to ESA to be developed with the funds of ESA. So it's usually 50, 60 pages. It depends, of course, of the number of annexes and how complex is your activity. And also, in the full proposal, if you will apply to elements 2, we will ask you to identify the business model, because we are asking you to think about the commercialization of the product that you will propose to us. If you are submitting in element 3, we are asking you the link to a national priority of the country where your company or institution resides. Then the contract is awarded and you develop the activities, and then you pave the way for the use or the business of this product. Next, please. So what can you propose it is very linked to what we discussed in what can you propose in this thematic window, because we decided to open a thematic window and to focus on the theme that we addressed this morning. So in elements 2, you will propose a technology that will demonstrate how imaging sensor and 3D models can assist, augment, compensate GNSS weaknesses when GNSS is in poor visibility. But you have to think about the commercial use of the product. A typical project in element 3 will be, for instance, a testbed development, a facility that will become an asset for your country and where you can demonstrate how your solution can meet the positioning requirements for the new mobility application. And we have seen that it is to guarantee accuracy, reliability, and ubiquity of the solution of the PNT for this autonomous transportation needs. So what are the use cases? Both private and public autonomous transportation, and we have seen waterways, road, and air. And what are the environment that we ask to address is where we have poor visibility of the GNSS. We have seen, thanks to our presentations of our very interesting speakers, that 3D models and imaging sensors can be used to map the surrounding vehicles, also to give absolute positioning, we have seen with Paul, to identify features of the environment that can be considered as obstacles for the autonomous car or vessels, and also predicting the poor visibility of the satellite, so when to use the satellite signals or not. Techniques can include, of course, artificial intelligence, cloud computing, because we need to process a big amount of data. So this is what we expect from you. Next, please, Emilio. So we don't have any requirements for the tenders. You can be a large, a small, a startup company. You can be a public institution, an infrastructure operator, a final user. You can build a consortium. Of course, the consortium shall reflect the fact that either you will propose a commercial product, either you will propose a product or an asset that is linked to a national priority. So you may involve a local government of a city, a mayor, a tram operator, and so on. Next, please. So where do you find the documentation to apply and to prepare your proposals? For element 2, it is on ISASTAR, which is our platform where we publish our opportunities. And the name of element 2 is Announcement of Opportunity 10.516. You have here the direct link to the ISASTAR, not always so easy to find in our platform where we have hundreds of announcement of opportunities. For element 3, the name of the announcement of opportunity is 9427, and here you can find the direct link. The most important documentation that you find there, it is an invitation letter describing the context of the call and the content and the structure of the outline proposal. Very simple document, the shorter, the better for us and for you. Then in the condition of tenders, you will find the guidelines for the preparation of the full proposal. I repeat, the full proposal is a complete document. And you also have the draft contract that provides the contract details. Many companies that approaches us that have never worked with ESA are a little bit investigating our draft contract closure. Please don't do that, because we really made all the amendments that we could to our general terms and condition of contract in order to be beneficial for you. For instance, you can keep the ownership of the product, which is one of the most important things for you that we use and put on the business market, the product. So we really review all the draft, all the contractual clauses in order to be beneficial for you, the tenders. And we cannot modify, so please take them as it is. It is easier for you and it is easier for us. Next, please. So now a little bit the time frame, the planning of this initiative on the Assissted GNSS for smart mobility in the cities. The two announcement of opportunities are already issued, beginning of June. We put a deadline, the 31st of October, so you are kindly invited to submit your outline proposal by this date. However, since the instrument of the announcement of opportunity that implements element 2 and element 3 is always open, you may also submit the proposal after this deadline. But please focus within these 3 months that we have ahead, including August, because we're really focusing and our experts are available to deal with the proposal on this specific theme. Next, please. Some recommendations. Okay, we will have on the week of the 6th of September, a dedicated session for bilateral questions with you. Independently of this specific session, you can interact with us whenever you have an idea, whenever you have a doubt on how to write the outline proposal, whenever you have any doubt, you can clarify with us, because I repeat, we are in direct negotiation and we are in confidential area. So please do not hesitate to contact us. We have a NAVISP website where we can find all the documentations, but also you can have a flavor of what we already develop and already are developing. When you decide to participate, please follow the guidelines. They are very, very precise, very, very detailed. We really ask we request the information that we need to evaluate your proposal. So be very, very strict to our guidelines. And any question you can send to these two address mail, NAVISP element 2, I will answer, NAVISP element 3, Rafael will answer. So this is the scheme. Very simple procedure to propose your idea. And the most important thing, it is that it is your ideas that you can propose to ESA, and ESA will support you with our technical expertise and we are with our financial funds. Thank you.
Thank you, Alessandra, for this nice view of how to engage with NAVISP. So now we are at the time of question and answers. We have a few minutes yet, so we'll try to filter some of the questions. First one is for you, Alessandra, just to shape the participation in NAVISP. We have two questions. Is rail out of the focus? And as well, is it needed a user in the proposals?
Okay, first question, no, rail can be in the proposal. The second question, no, we don't need a user. It can help because it can set for you the requirements, but it's not a requirement for the participation.
Thank you very much. Now let's go to some questions to Paul Groups, your presentation.
Olivier,
yes.
Sorry to interrupt. I think that Sonia has to leave in shortly in a few minutes. Can we ask to Sonia the question about we received the question of you have presented the status of the maps mostly for land navigation for cars. What about waterways and what about rail?
Yeah, I saw
Sonia?
the question on lane navigation. So we did work with Deutsche Bahn in the past, and I think we're still working with them, though I can't go into the details of the project. I think in that case, it was about using not just positioning, but also a digital track map, right? So it was not purely based on a positioning service, but it was based on positioning and a track map and other complementing technologies. But I think the positioning accuracy that in that case we were aiming for was 1 to 2 meters. because that was what was under discussion. And again, I think it depends really on the use case, because navigation has many different underlying use cases. But yes, technically we can extend the same approach also to train navigation.
And what about waterways? Because it seems to be an important mobility case for the future cities.
Yes,
Waterways.
I have to admit, I've personally not worked with a customer doing the waterways, which sounds weird now, given that I live in the Netherlands. So maybe I have to fix that. But I also see this extending to waterways, though I can't speak for the positional accuracy, because honestly, I don't have experience there, but I can follow up and get back to you.
Okay, perfect. So Olivier, back to you.
Yes, I have a question here that may be also for Sonia. So the question is long. Collection of all data of all
I
types
saw
of...
that, yes. I can take that question. I was going
Perfect.
to reply in the chat. They actually end the question, yes, it is a necessary evil. I don't think we can survive without having a connected service. In fact, all OEMs are working on this, right? Every single OEM is working on having a cloud infrastructure, because the OEMs, they want to trust their own backends. So even if Here provides a solution to them, the solution actually is hosted by Here, but it could be in the OEM cloud. And they have a cloud to car streaming. But what they also do is they have backups in place. So there's always a very robust caching strategy in place. There's always something off board, so something that can be used as a fallback in case of complete loss of connectivity. And of course, they're always looking at what kind of connectivity information they have available to them. But yes, we cannot get away from all the solutions being streamed to the vehicles, because that is the future. And the only way to do this is to embrace it in a way that we have backup in case the connectivity drops off.
Thank you, Sonia. So now time for a set of questions to Paul groups. First one is why we should avoid dual frequency iono corrections in urban environments.
Okay, so the way dual frequency correction works is you take the measurement on one frequency, multiply it by around 2.5, and subtract it with the measurement on the other frequency multiplied by roughly 1.5. So the multipath errors on the two frequencies will be independent of each other, because they depend on the phase phase delay. So when you combine the work out the standard deviation of the multipath, what you're doing is a root sum of squares. So if you take 2.5 squared plus 1.5 squared, take the square root, that's roughly a factor of 3. So if the multipath error is the same on both frequencies, you've expanded it by a factor of 3. But it's actually worse, because the multipath error on the higher bandwidth signal, the L1 signal, will be higher than the multipath error on the wrong way around. Yeah, the multipath error on the low bandwidth signal, the L1 signal, will be higher than the multipath error on the high bandwidth signal on E5 L5. So you're actually increasing the multipath error by more than a factor of 3. So as soon as you do dual frequency correction, you're throwing away all of the accuracy benefits of using L5 E5. So the best way to correct ionosphere is using corrections from a reference data service. So, I mean, for example, you could use the EGNOS corrections or corrections via assisted GNSS.
Thank you, Paul. So there is a second question for you. The 3DMA methodologies presented seem to aim at positioning on ground. What level are they usable for drones in urban areas?
Okay, so on the ground, you have the advantage that you essentially know your vertical position. So you're, say, 1 meter to 1.5 meters above the ground, typically. So you can constrain your search area of candidate positions to two dimensions. As soon as you go up in the air, you have a three-dimensional search area. So that massively increases the processing load of 3D mapping aided GNSS techniques, which makes it impractical. So what you need to do is get an independent height solution using maybe a barometric altimeter or ultrasonic altimeter or a radar or laser or something, so that if you can constrain your height to within a meter or so independently of GNSS, then you're able to basically just maintain a 2D search area, but you raise it up according to whatever your computed height solution is.
Thank you, Paul. I would like to address now two questions for Alessandra to clarify a bit as well the scope for the companies, how they should be. So one is, can you provide example indicative project cost and duration for tender with UK-based companies?
Yes, as I was saying, it is very, very valuable because it is the company that proposes an activity. So we can have very different size and duration for the contract, for the activity. We can have couple of hundreds euros up to 2 million of euros. We can have duration that typically are from 8-12 months to 1.5 2 years at the maximum, because we are really trying to realize product that can be either useful to the nation or ready for commercialization. So a very wide range of size and duration of the activities of the project.
Thank you, Alessandra. Another one is, how rigid is the focus of the call in mobility? Will contributions related to GNSS science use cases fit, I believe? Example, atmosphere, remote sensing.
Well, the scope of this call is specifically on mobility. But if any ideas can be submitted into element 2 and element 3. This specific call is specifically on mobility.
Correct. Okay, then let's go back to Paul. So on slide 7, but anyway, the focus of the question is that you focus only about accuracy, but not about safety, which should rely on it. So how is safety integrity managed?
So integrity in urban areas is a very difficult problem. I'm not sure whether the aviation-based approach is even workable. With 3D mapping aided GNSS, you're not just considering failure modes within the GNSS signal. You also have to consider failure modes within the mapping. Is the mapping out of date? Is there a construction site? And then you've got features in the environment, such as buses and trucks, for example, that are never going to be on mapping. I think probably we need to break the integrity problem into two stages. First of all, selecting what information we're going to use for the position solution, and then verifying the integrity of position solution. So, for example, you could generate a 3D mapping aided GNSS solution. When you've got that solution, you go back to the mapping, you identify signals you can trust. You could then compute a conventional GNSS solution with the signals you've selected, and apply conventional GNSS integrity techniques to that. But that only works where you've got good signals. In all honesty, I'm not sure whether the integrity problem is solvable in complex urban environments. I mean, I would say just don't use the position solution for safety of life. You know, use LiDAR and cameras to detect obstacles. Trying to avoid obstacles using positioning is crazy, because not only do you need your own position accuracy, you need the position of every object around you, every traffic cone, every small child, every dog. You can't put a positioning device on every single object in the environment and use that and then transmit that to every vehicle. It's just not practical. So I think by asking about the integrity of a position solution in a challenging urban environment, I think he's almost asking the wrong question. We need to sense what's around us to keep safe, and just use our PNT solution to guide us around, ensure that we're following the right route to our destination. And then if something does go wrong, then we just have to turn around and correct our journey, just as we would do with a manual driver.
Thank you, Paul. I think we have reached the time limit. I don't know if we have, Rafael, still time for a last question to Alison.
Yes, please. I think Alison is still there.
Yeah, perfect. So the question is if NVIDIA is working with car manufacturers to deploy autonomous car solutions. You mentioned Volvo in one of your slides, but for a complete solution?
Yeah, complete solutions. This is what our Drive platform is about. It's basically a specialized version of the GPU-based elements across the board that can accelerate the vast number of algorithms that are needed. And you can actually pull down the code for many of these. You have so many different aspects in the actual full solution that you need dedicated hardware. But also I wanted to emphasize, for so far as safety, I've put the link in the chat for our safety report on NVIDIA Drive. Simulation is a massive part of the work we do. It's not just Volvo. We work with Mercedes, Daimler, pretty much 99% of automotive manufacturers, and that includes training services. There's a link there from SBB, who've given many talks at GTC on how they use our hardware and software. The simulation is really key. This is a virtual environment that is physically enabled, so it's physically accurate. You have photorealism. We can construct. There's lots of research that use just small pockets of environments that have been reconstructed to very, very minute detail. But for example, you can reconstruct most of New York City, and a lot of automotive or across the board autonomous vehicle training is done in simulation. And we've actually put out peer-reviewed papers that explain why the fusion of simulated training as well as real-world data from actual fleets driving around the roads combined makes a much more robust solution than just real-world data, because we cannot cover the training with artificial intelligence for the various corner cases, for the unknown unknowns. But you can do this in a virtual environment. I didn't have much time, but I briefly showed what we mean by domain randomization, where you can alter the lighting, you can alter whether there's trees or not, whether there's pedestrians or not, whether there's a truck in front of you or a bus in front of you. All the millions of variations can be very, very rapidly included in a simulated environment, and so it's widely used. So have a look at Omnibus. It's got an open beta right now, and you can actually use it to help. But a lot of it is proprietary at the moment for the automotive, field, for the simple fact that obviously it's very competitive.
Thank you very much. There is one last question we have here registered that I could even answer myself and pass to the others. What future is there for land-based PNT either as supplement or to replace space-based signals? My view here is that the challenges are multidimensional, and all aids that can be used to augment the GNSS and to provide a reliable positioning and navigation will be welcome. So there still be some room to use them, or even a signal of opportunity that can be used as well. Anyone wants to add something else?
Yes, Olivier, I would like to take the floor again because I have a couple of questions by Darren Price and Pepe Molina. So what is the co-funding rate? The co-funding rate depends on the size of the company. We can fund up to 50% for large companies and up to 80% for small companies. Public institutions are funded 100%. What does it happen when we have mixed consortia from different countries? This co-funding share is the same for any participant to the consortium. And of course, the support of the delegation shall be searched and obtained from each delegation from each country of the member of the consortium.
Okay, I think we covered the majority of the questions. We are running out of time. Rafael, Alessandra, any other question that is still in the chat warm there, or we can we proceed to close this successful webinar?
I think that we have covered most. We will go anyway through all the questions, and if there is something not answered, we will try to provide an answer by email. Yeah. Okay.
Perfect. Very good. So thank you, everybody, for your participation, your interest, your questions, as well for the people that has been working in the background, assisting and making this possible. And as Alessandra pointed before, there would be an informative session in September as well. And you can always reach us for additional questions. So thank you very much, and enjoy the rest of the day.